6 is your position, minus 1, then you get minus 486. That's your final answer. Now let's look at quadratic sequences. So a quadratic sequence is a sequence where the second difference between consecutive terms is constant. So this is the general formula of the quadratic sequence. As you can see, it looks like a quadratic equation. Okay, so now let's take for an example the sequence 1, 4, 9, 16, 25. First, we're gonna check for the first difference, which here is 4 minus 1 is 3, 9 minus 4 is 5, 7, 9. Okay, and then we'll minus 5 and 3 to get the second difference, which is 2. 7 minus 5, 2. This is the common difference. Let's look at an example. So it says find the sixth term of 3, 8, 15, 24. We're going to do the same thing. Find the first difference and then find the common difference, which is your second difference. Okay, so since it's 2, to find the fifth term here, you're going to plus the 24 by 11. You get 35. And then to get this first difference here, you'll say 11 plus 2. You'll get this. And then to get the sixth term, you'll plus 35 and 13 to get 48. Okay, so that's your sixth term. Okay, so now let's look at the problem. It says identify the next term in 2, 6, 12, 20. Okay, so we first gonna find the first difference, which is 4, 6, 8. Okay, and then find the second difference, which is 2, 2. Okay, so to find this here, we're gonna add 8 plus 2 to get 10. And then to get the next term here, we're gonna add 20 plus 10 to get this term. That's 30. That's your answer. Okay, so now let's look at this question here. It says write the seventh term of this sequence here, 5, 12, 21, 32. Okay, so we're gonna say, let's first find the general formula. Okay, not the general formula, man, the general formula. Okay, so Tn a n squared plus bn plus c. It's supposed to be like this. Okay, so now the first difference is 7. Okay, 9, 11. Okay, and then the second difference is 2, 2. Okay, so you're going to use this method. Please follow me, please. 2a equals 2. Now we're trying to find a, b, and c. So 2a equals 2, your second difference here. So your a equals 1. Okay, and then we're gonna use this formula as well, but in this case we use the first difference, which is your 7. Put 7 here and then substitute a here. So 3, 1 plus b equals 7. Okay, so 3 plus b equals 7. So b equals 7 minus 3, which is 4. Then to find our c, you say a plus b plus c equals to the first term, 5, and substitute your a and your b into the equation. Okay, so our a is what? It's 5 plus our b is 4 plus c equals 5. Okay, so now our c equals 5 minus 9, c equals minus 4. So our general formula is a n squared, our b is 4, and then our c is minus 4. Okay, so now they said find the 7th term of that sequence. So we're going to say T7 equals our first term, which is 5. The position is 7 squared plus position, still 7, minus 4. Put that into your calculator. You get 269. That is your final answer for this question. Okay. The third question says, what is the second difference of this sequence? Okay, so let's work it out. First difference is 5, 16, 7. I'm guessing it's 9. Yeah, it's 9. 2, 2. Your second difference is 2. That's your final answer. Okay, so now let's look at the Fibonacci sequence. So a Fibonacci sequence is a sequence where each term is the sum of the 2 preceding terms. Okay, so this is the general formula of a Fibonacci sequence. Okay, let's look at an example. It says write the next 3 terms of the sequence 0, 1, 1, 2, 3, 5, 8. Okay, so 2, 4, 6, 7. So to find the 8th term, you're gonna add the 7th term plus the 6th term, which is T8 equals T6 plus T7. It's 8 plus 5, 13. Okay, that's your 8th term. Your 9th term is your 7th term plus your 8th term. So what you got here plus 8 gives you 21. Okay, to get the 10th term, you're going to say T8 plus T9. It gives you 34. That's how we work out a Fibonacci sequence. Okay, and please note that the first term of a Fibonacci sequence is always 0 all the time. All the time. Okay, so here they're saying write the first 10 terms of the Fibonacci sequence. Okay, so we start with 0, 1, 0 plus 1, that's 1, 1 plus 2, 2, 3, 5, 8, 13, 21, I'm guessing. Let me see. 8 plus 13, yeah, that's 21. 21 plus 13, that's 34. Okay, 2, 4, 6, 8, 10. This is the first 10 terms of a Fibonacci sequence. This is how you write them. Exactly like this. Okay, so now let's look at another problem. This question says, what is the 8th term of the sequence 1, 1, 2, 3, 5, 8? So 2, 4, 6. So 5 plus 8, 2, 2, 4, 6. 5 plus 8, 13. Now T8 is 13 plus 8, which is 21. Okay, this is your final answer here. 21 is your final answer. Okay, So let's look at the last question. It says if T1 is 2 and T2 is 3, what are the next 3 terms? So 2, 3, okay. 3 plus 2, that's 5. 5 plus 8, 13. So the next 3 terms are 5, 8, and 13. Okay, this is your final answer here. Now let's look at the harmonic sequence. It is a sequence where the reciprocals of the terms form an arithmetic sequence. I'm sure you know what a reciprocal is. So a reciprocal of 1 over 2 is 2. Of 3 over 2 is 2 over 3. Those are reciprocals of each other. Okay. Okay. So let's move on. So if you're given a harmonic sequence like this, the reciprocal sequence of that sequence, it's going to be like this: 1, 2, 3, 4. It forms an arithmetic sequence. Okay, so let's look at an example. Write the fifth term of 1, 1 over 2, 1 over 3, 1 over 4. So the fifth term will be 1 over 5. I'm sure you understand. Okay, so let's look at the problem. Let's look at problem 1. It says write the sixth term of this sequence. So the sixth term obviously will be 1 over 6, since the fifth term is 1 over 5. Okay, so that all of the denominators, they are added by 1 to give the next term. Okay, so let's move to the last but not least. If the fourth term is 1 over 8, write the corresponding term in its reciprocal sequence. It's going to be 8. Okay, this is your final answer, 8. You just find the reciprocal of this number. It gives you the corresponding term. Okay, so let's move to non-linear sequences. Okay, these are sequences that do not follow a clear arithmetic, geometric, or quadratic rule. The terms may seem random or follow an unpredictable pattern. Look at this example: 2, 4, 8, 3, 9, 27, 7, 49, 3, 43, right? So this is the analysis. This is how you analyze it. If you look at the first 3 terms, they follow this exponential sequence, this exponential pattern, sorry. Okay, so the first 3 terms follow this. If you say 2 to the power 1, you get 2, you get the first term. If you say 2 to the power 2, you get 4. 2 to the power 3, you get 8. But 2 to the power 4 doesn't give you 3. Okay, so it changes from here. The pattern changes from here. Okay, so the second group follows this pattern here: 3 to the power n. Sorry. Okay, so 3 to the power 1 is 3. 3 to the power 2 is 9. 3 to the power 3 is 27. And 3 to the power 4 is not 7. So it changes again here. Okay, so the third group follows 7 to the n. Okay, so 7 to the 1 is 7. 7 to the 2 is 49. 7 to the 3 is 343. Okay, so this sequence alternates exponential patterns. Okay, so this is the end of our video. In the next video, we're going to focus on more problems. We are going to do more problems, and yeah, we're going to do more problems of this chapter. Good luck.